Welcome, ladies and gentlemen, to your MN21 notes, where we're going to talk about congruent figures. The definition of a congruent figures is when we have all corresponding sides and angles are congruent. Okay, so if you have all corresponding sides and angles are congruent, then you have congruent figures. So let me show you kind of what we're talking about in example number 1, where it says write a congruence statement for the triangles, identify all pairs of congruent corresponding parts. I'm actually going to do it backwards. I'm going to first talk about our corresponding parts that we know are congruent. So I'm starting right here at the star. Corresponding angles. So if we have angle A looking at the other shape, we know that angle F is congruent. Just like if we have angle B, we know, just because it has one arc representing the angle there, we know that angle G is congruent to angle B. And then angle C is congruent to angle H. Corresponding sides, if we know that AB, or we know that AB is going to be congruent to FG. Why? Because we have those two hash marks showing that this side right here, AB, is going to equal the length of GF. And then you can do that for the other two as well. So BC is congruent to GH, so line segment GH, and CA is congruent to FH, line segment FH. So now we've shown that all corresponding angles and all corresponding sides equal, so then we can create what's called a congruence statement, which is very, very powerful. So let me just kind of start by this. We know up here, now I'm on this first spot, it says the diagram indicates that triangle ABC is congruent to, and since we're starting right here with A, we want to start this next triangle with F because A and F are in the same position in the congruence statement and they also are congruent. So F, and then we see B is the next, so ABC, B is the next angle, and G corresponds with angle B, and then H and C correspond. So it's just really be careful with that congruent statement to make sure that it's in the proper order. So this right here is a congruence statement. It is extremely helpful in finding congruent parts. Why? Because you can look at it, and if, for instance, we are interested in angle C, we can just look at the congruence statement and know that angle H is congruent to that. Or, let's say we're talking about angle or side length BC right here, we know that GH segment is going to be congruent. So that congruent statement is very, very helpful, and the order does make a difference when you're writing that statement. So looking at this example number 2, it says in the diagram we have quadrilateral QRST is congruent to WXYZ. Without me even looking at the picture, I know that angle Q is going to be congruent to angle W, angle R is congruent to angle X. How do I know this? Because just looking at this right here, which is a congruence statement. And I can keep going. I can find all the angles and all the side lengths that are congruent. So that's a congruent statement, very powerful. So down here, it's asking us to find the value of x. Now, they're not saying angle x. What they're asking for is the variable x. So really, if you look, here's where that variable x is all kind of by itself of 5x plus 5. That represents angle w. What we need to do is figure out what angle is congruent to angle W. And again, you can just look up here at the congruence statement and note that it's angle Q, or you can look at the diagram and figure it out that way as well. So angle W is represented by 5x plus 5, and angle Q is represented by 65 degrees. And to find the value of x, we are just solving a nice little linear equation here, subtracting 5 from both sides. So we have 5x equals 60. Divide out by 5, we have x is equal to 12. So that is the unknown variable x. So very similar, finding the value of y, we're going to look, and I'm going to switch colors here. We're going to look at the equation. Now we're not talking about angle y. I can understand the confusion, but that's a capital W or capital Y, where this is literally, this is a lowercase y, which is represented right there, y minus x. So this, if you look over there, you have WX line segment, and you need to figure out what segment is congruent to WX. And again, you can come up here and look at your congruent statement. Here's WX right here. And I know then QR, since it's in the same placement, is going to be congruent. Now, if you prefer looking at the diagram, by all means, do whatever works for you. Excuse me. So WX is represented by y minus x, and QR is 6 inches. Now, this would be a difficult equation to solve if we hadn't solved for x already, but we have in the previous examples. So we have y minus, but instead of x, we're going to substitute that 12 in. And now we can just solve for y by adding 12 to both sides. So we have y is equal to 18. So this is just using congruence in the congruence statement to solve a couple of algebra problems. This third angle theorem is essentially saying that, hey, if you know angle A is congruent to angle D, B is congruent to E, then we know that angle C is going to be congruent to angle F. So we know angle C is congruent to angle F by what's called the third angle theorem. So let me just fill in the blank here. It says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. And we just use the symbol there. Well, how can we use this in an actual kind of problem? This example 3 is going to use that idea. And what we're trying to do is find angle V. This is the unknown. So if you look, let's just fill in what we know within this triangle right here. We know angle W is going to be congruent to angle T because of the notation. So we know this is 66 degrees. We also know that this angle right in here is 44 degrees because of vertical angles. So if we know that angle U right here, actually VUW is 44 degrees, W is 66 degrees, we can figure out angle V by taking 180 degrees and taking away the 44 degrees and the 66 degrees. Then when you calculate that out, you'll find that the remaining amount of degrees left for V is 70 degrees. So angle V is going to be equal 70 degrees. Now there is a back to this note guide, but we are not interested in doing the back of this note guide. At this point, you are done with this MN21 note guide, section 4.2. When you come on in tomorrow's class, we'll take any questions you have. Thanks for joining me.